Alright, so today we're going to talk about doing single operation division in algebra. So we have two different expressions up here. We have 4 multiplied by y equals 12 and 12 divided by x equals 4. Now both of these use the same parts, and we know that multiplication and division are inverse operations, but we can't solve these the same way. So let's take a look up at the multiplication one first. We know that anything we do on one side of an equation we have to do on the other side. So we're going to divide both of our known values by 4, given that division, is the opposite of multiplication. And what we end up with is 1 multiplied by y equals 3. Now we know that any number multiplied by 1 is itself, and so we can basically cancel out 1 multiplied by y, which gives us y equals 3. And this works well with multiplication. Now, another way we could have solved this same multiplication problem is by moving things around. Now, to remove something from one side of the equation and place it on the other side is, as long as we do it right, is the same thing as creating parity on both sides. So instead of 4 multiplied by y equals 12, we're just going to move the 4 over to the other side. And because 4 was being multiplied, and it doesn't matter which multiplier we take, it's an inverse operation. It becomes 4 divided by 12, so y equals 3. Now both of these methods work well, but they can't both always be used when solving a division problem. If we take that second method I just showed you for multiplication, and we look at this 12 and we say, oh, well, the inverse operation of division is multiplication, so I'm just going to multiply 4 by 12. And what I get out of that is a product of 48. Now that's not possible. If my problem was x divided by 12 equals 4, then sure, yeah, because my dividend would be larger, but in this case 12 is my dividend. And in any whole number division, the largest number is always the dividend. So x, my divisor, can't be 48. All right, we know through logic that it has to be a much smaller number. What we're going to do here instead is we're going to swap x and 4. All right, and because this is a single operation algebraic expression, we can do that. All right, x doesn't become a negative, 4 doesn't become a negative. It's an equal swap, and we end up with 12 divided by 4 equals x, which is 3. And so x equals 3. Now, let's take a look at different parts of a division problem again, because I was using some words that you might have forgotten. Dividends, divisors, and quotients are all part of a division problem. The dividend is the whole. This is the part that's being partitioned. It's your group of apples. It's your number of people in a crowd. The divisor is the equal groupings of the whole. So what we're going to break this larger number into. And your quotient is the total number of groupings. So how much you're going to have at the end. How many groups you're going to have at the end. Okay? Your dividend is always larger. The only time it's smaller is if you're doing decimal division, where you know your quotient is going to end up being a decimal number. And so while we can do inverse operations when our dividend is unknown and move our divisor to the other side and multiply it, we cannot do that when our divisor is unknown. When our divisor is unknown, we must instead swap our divisor and our quotient and divide our known values to get our unknown value. And I'm going to show you what I mean here. In this first problem here, 12, the dividend, is known and the divisor is unknown. An easy way to remember that you can't do inverse operations here is that the actual division operation is to the right or behind the known value. So if we were to just move 12, there is no operation attached to 12. So what we're going to do here instead is we're going to swap x and 4, a known value, for an unknown value. So instead of having 12 divided by x, we're going to have 12 divided by 4. Now this works because the divisor and the quotient are interchangeable the same way multipliers are interchangeable in a multiplication problem. So 12 divided by 4 equals 3, which means x equals 3. Now if we look down at the second problem, this problem is much easier because the dividend, our larger value, is unknown. Now I just said that the divisor and the quotient are interchangeable. That means they're the two parts that make the dividend. What this means is we can use inverse operations here. So there's two different ways that we can do inverse operations. The first is quite simple. Anything we do to one side, we have to do to the other side. There's no flipping things around. Visually, this is quite easy to see. So, since 3 is our smaller number, and our base operation is division, we're going to use an inverse operation. We're going to multiply. So, on the right side, we're going to multiply 12 by 3. And on the left side, we're going to multiply 3 by 3. Now since this is divide 3, multiply by 3, these two operations on the left side cancel each other out because they're valued at the same thing. So we can you would just draw a circle, and there's no net gain, no net loss here. These just cease to exist. So now we're just left with x on the left side and 12 multiplied by 3 on the right side, which gives us x equals 12 multiplied by 3, which would be x equals 36. Another way we can do this that's a little bit faster but also offers you more chances for error is to move this divide 3 to the other side of our expression. Now when this happens, the division symbol comes with it, and it changes into multiplication, the same as a subtraction symbol would turn into addition when moving from one side of the expression to another. So let's quickly do that here. Instead of x divided by 3 equals 12, we're going to write down x equals 12 multiplied by 3. And we get the same answer of x equals 36. So that's just another way that you can solve for an unknown when your unknown is the divisor in a division expression. So just to recap, when the dividend is known, you cannot use inverse operations. Instead, switch your quotient and your divisor around, your known and your unknown value, and leave the division operation there. And when your dividend is unknown, you can use inverse operations by moving your divisor over to your quotient and multiplying it, or by multiplying your divisor on both sides.